Hi students, welcome to DSR Maths. Today we will discuss problems on modulus. These are the most important problems. Listen carefully. So before that, some basic problems I will give. So in the last class we discussed if a greater than 0, modulus of x equal to a means x equal to what? Plus or minus a you taken, and the second one is modulus of x less than a means minus a less than x less than a, or less than or equal to means here less than or equal to, and modulus of x greater than or equal to a means x is less than or equal to minus a, and x is greater than or equal to a. These three are important ones. So based on this, some basic problems I will do. After that, we will go to the main problems. Okay, now? Right. In that first problem, if you take suppose modulus of x minus 2 equal to 4. So we know that modulus of x equal to a means modulus of x equal to a means x equal to plus or minus a. Means in place of a 4 is there, in place of x mod x minus 2 is there. So therefore it can be written as x minus 2 equal to plus or minus 4. Here there are two cases, x minus 2 equal to plus 4, and the second one is x minus 2 equal to minus 4. That implies x equal to, here what you will get, 6 you will get, and here x equal to minus 4 plus 2, that is equal to minus 2. So here x equal to minus 2. So these two are solutions of the given equation modulus of x minus 2 equal to 4. You verify this one by substituting here modulus of 6 minus 2 4 equal to 4, or this one you substitute minus 2 modulus of minus 2 that is equal to modulus of minus 4, that is equal to 4 only, right? Next, take one more problem like this. Modulus of 2x plus 5 equal to 8, like this. If you take, so here also you can write it as 2x plus 5 equal to plus or minus 8, because it is in the form of mod x equal to a. Now if you simplify this one, so here also two cases you take. First case is 2x plus 5 equal to 8, and second one is 2x plus 5 equal to minus 8. Now that implies 2x equal to 8 minus 5 is 3, and x equal to 3 by 2. Right? This one take that side, 8 minus 5 3, and 2x equal to 3 by 2. Next here 2x equal to minus 8 minus 5. X equal to this minus 13 by 2. Right? Now these two substitute in this one. So these are the two solutions of the given equation. Substitute here x equal to 3 by 2. If you substitute modulus of 2 into 3 by 2 plus 5, 2 get cancelled, 3 plus 5 equal to 8. And substitute this one also, modulus of 2 into minus 13 by 2 plus 5 get cancelled, modulus of minus 8 equal to 8 only. Like this we will do. Next, if you take like this, third one, modulus of x plus 2 less than 6 is there. So it is in the form of what? Mod x less than a. That implies how to write it as minus a less than x less than a. Now in place of a what is there? 6 is there. In place of x, x plus 2 is there. Now minus 6 less than x plus 2 less than 6. Now here we want only x. We have to eliminate plus 2. So for that minus 2 plus 2 less than x plus 2 minus 2 less than minus 2, subtracting minus 2, right? So here minus 2, here also minus 2, here also 6 minus 2, that is minus 8 less than x less than 4. So this is in the form of mod x less than a. So it can be written as minus a less than x less than a. Now here in place of x, this one is there. In place of a, 6 is there. So minus 6 less than x plus 2 less than. So we have to eliminate this minus means plus 2. For that one adding minus 2. Here also minus 2, here also minus 2. Minus 8 less than. Now minus 8 less than x less than 4. From this one, any value substitute satisfied or not, you check. So minus 8 to minus 4. So here x exists from where to where? Minus 8. Here 4 is there. Substitute minus 7. Minus modulus of minus 7 plus 2 less than 6. Modulus of minus 5 less than. So 5 less than 6. Satisfied or not? Next, suppose less than for any one value. 0 also you can substitute. 0 plus 2 less than 6. 2 less than 6. Otherwise, 3.9. Modulus of 3.9 plus 2. Definitely it is less than 6 only. But if you take greater than 4 and less than minus 5, it is not satisfied. So that's why our solution is minus 8 less than x less than 4. Now take one more problem. Suppose they given modulus of 2x plus 3 less than 5 less than or equal to 5 given, suppose. So what we have to do? So here also it is in the form of mod x less than or equal to a. Minus a less than or equal to x less than or equal to a. In place of a 5, in place of x 2x plus 3. It can be written as minus 5 less than or equal to 2x plus 3 less than or equal to 5. Now here also only x we want. For that one eliminate this 3 and 2. For that minus 3 you take minus 5 minus 3 less than or equal to 2x plus 3 minus 3 less than or equal to 5 plus 3. Right? Now minus 8 less than or equal to. So these two get cancelled. 2x plus that less than or equal to 8. Once again see minus 3. Minus 3 here, minus 8. Next here minus 3. So that's why what you will get here? 2 you will get. Now divide by 2. Minus 4 less than or equal to x less than or equal to 1. So this is our solution. So from this one any one value substitute exists. So minus 4 to 1, 0 you substitute. 3 less than 5 only. So between minus 4 to 1 and including minus 4 and 1, any value substitute, it is exist only. Next, if you take one more problem like this, modulus of x plus 1 plus 2 equal to 5 is there. So how to do? So here also what we have to do, modulus of x plus 1 equal to, this one take that side, 5 minus 2. Modulus of x plus 1 equal to 3. So modulus of this 2 bring this side, 5 minus 2 equal to 3. Now modulus of x plus 1 equal to 3. Now it can be written as again modulus of x plus 1 equal to 3. Again here 2 cases. What are they? X plus 1 equal to 3. Second one is x plus 1 equal to minus 3. Now x equal to 3 minus 1 2. Here x equal to minus 4. So these are the solutions of the given equation. Substitute x equal to 2. 2 plus 1 3. 3 plus 2 equal to 5. And substitute x equal to minus 4 also. Minus 4 plus 1. So minus 3. Modulus of minus 3 plus 3. 3 plus 2 equal to 5. So these are the required solution. Suppose here any inequality less than is there and greater than or is there, less than or equal to, greater than or equal to, same thing we have to follow, same procedure, but here less than, greater than we have to take. Next, suppose like this they given modulus of x plus 6 greater than 8 given. So it is in the form of what? Mod x greater than a. Mod x greater than a means how to write it as x less than minus a, x greater than plus a. So in place of a, 8 is there, in place of x, x plus 6 is there. So x plus 6 less than minus 8 or x plus 6 greater than 8. Now that implies, simplify this one, x less than, bring this side, minus 8 minus 6 and x greater than 8 minus 6. That implies x less than minus 14 or x greater than So our solution is this one. So which value satisfies this what inequalities? Satisfies this inequalities also. Substitute x less than -4 any values means here anywhere -14, here 2 is there. X less than -14, -15 you substitute. Modulus of -15 plus 6 greater than 8. Now this is -15 plus means modulus of -9 greater than 8. 9 greater than 8. Satisfied or not? And any value greater than 2 also you substitute in this given inequality. So modulus of, suppose if you substitute 2.1, so 2.1 plus 6 greater than 8 means 8.1. 8.1 greater than 8 only. Suppose between these two any value if you substitute it will not satisfy given means substitute x equal to 0. 0 plus 6 not greater than 8. So like this some basic problems. So same concept we will apply on next problems also. Problems are there. Take the first problem, that is modulus of mod 2x plus 3 plus 1 equal to 4 given. We know that this is if you take as x, modulus of x equal to a means x equal to plus or minus a. For that modulus of 2x plus 3 plus 1 equal to what we have to take plus or minus 4. Now here two cases again, 2x plus 3 plus 1 equal to plus 4. Next modulus of 2x plus 3 plus 1 equal to minus 4. Right? Now from this one modulus of 2x plus 3 that is equal to minus 5. So this is positive means greater than or equal to 0. It is negative. So it is not possible. So that's why we can remove this one. So only we have to simplify this one. So that is here again two cases. Modulus of 2x plus 3. If you simplify 1 bring this side, what will get? 3 you will get. Now what is the first case? Modulus of 2x plus 3 means if you write it as 2x plus 3 equal to plus or minus 3. So first one is 2x plus 3 equal to 3, and second one is 2x plus 3 equal to minus 3. Now here 2x equal to 0, x equal to 0. Now here 2x equal to minus 6, x equal to minus 3. So these are the two solutions of the given equation. Substitute x equal to 0, modulus of 3 plus 1, 4. X equal to minus 3, minus 6 plus 3. Modulus of minus 3, 3 plus 1 equal to 4. Right? This is about the first problem. Next, take the second problem. So that is modulus of x minus 1 less than or equal to 5 is there. Modulus of x greater than or equal to 2. Means this solution and this solution we have to find. After that we have to take the intersection. Now for that it is in the form of what? Mod x less than or equal to a. No? So this can be written as minus 5 less than or equal to x minus 1 less than or equal to 5. We know that whenever modulus of x less than or equal to a, that can be written as minus a less than or equal to x less than or equal. Now you have to eliminate this minus 1. For that what we have to do? Add plus 1 less than or equal to x minus 1 plus 1 less than or equal to 5 plus 1. So that is minus 4 less than or equal to x less than or equal to 6. Right. This is equation number 1. Next here modulus of it is in the form of mod x greater than or equal to a. So if any equation inequality if it is in the form of mod x greater than or equal to a, that can be written as x less than or equal to minus 2 or x greater than or equal to plus 2. Take this as equation number 2. So if you take some values means solutions of these two means that solution satisfies simultaneously first inequality and second inequality. For that definitely what we have to take? Intersection only you have to take. 1 intersection 2. Now 1 intersection 2, these two values take on number line. So here minus 4, here minus 2 and here 2, 6. So this one is minus 4 to 6, means closed interval, because equal to also there. So closed interval means a closed circle we have to take like this. Now here x less than or equal to minus 2. This is x less than or equal to minus 2 and x greater than or equal to plus 2. X greater than or equal to plus 2. Now from this one common values we have to take. So common values are what? Here to here and here to here. Means x belongs to, from where to where? Closed interval, minus 4 to minus 2 union 2 to 6. This is our required solution. Means if you substitute in this one any value which is satisfying, so this one also satisfies these two simultaneously. Okay, no? Right. This is about the second problem. Next, take the third problem. If you take the third problem, both are same only, but this is a combination of this one. They only like that only they given. Third problem is 1 less than or equal to modulus of x minus 1 less than or equal to 3. Here separately given. So here how to write it is also 1 less than or equal to modulus of x minus 1. Next modulus of x minus 1 less than or equal to 3. So this is first one and this is second one you take. Now from this one, so modulus of x minus 1 greater than or equal to 1 if you write. So again it is in the form of what? Mod x greater than or equal to a. This can be written as x minus 1 less than or equal to minus 1 or x minus 1 greater than or equal to plus 1. So x minus modulus of x greater than or equal to a means x less than or equal to minus a, x greater than or equal to plus a form. Now this is x less than or equal to 0. Bring this side. So what you will get? X less than or equal to minus 1 plus 1 means x less than or equal to 0. Or here also bring that side. X greater than or equal to 1 plus 1 means x greater than or equal to 2. Take this as equation number 1. Next come to second one. That is it is in the form of mod x less than or equal to a. Means this can be written as minus a less than or equal to x less than or equal to. By that form, so how to write it as minus 3 less than or equal to x minus 1 less than or equal to 3. Now simplify this one. Minus 3 by adding plus 1, minus 1 plus 1 less than or equal to 3 plus 1. So minus 2 less than or equal to x less than or equal to 4. Take this as equation number 2. Here also what we have to take common solutions of equation number 1 and 2. So 1 intersection 2. Here also these values take a number line and the common solutions you find. So this is minus 2, here is 0, 2 and 4. So less than or equal to 0 means this side. Greater than or equal to 2 means this side. Next, x is minus 2 to plus 2 means here to here. Now what are the common values? So minus 2 to 0 and 2 to 4 means x belongs to, it can be written as x belongs to closed interval minus 2 to 0 union 2 to 4. Can you write? So from this one any value substitute in this one, that is satisfies only. Suppose 0 if you substitute here 0, 1 less than or equal to 1 less than or equal to 3, satisfied or not? Like that any value substitute in this one that satisfies this inequality, given inequality, right? This is about the third problem. Next, take the fourth problem. That is modulus of x minus 1 plus x minus 3 equal to 2. So how to simplify? Last video we did one problem based on this one. So here there are two methods are there. Two methods we have to discuss. Two methods are important. So first one is mod x plus mod y equal to mod of x plus y is there, means here xy greater than or equal to 0. So in the last video we discussed this standard condition. Is it satisfying this condition or not? Once you see, if you write this one as modulus of x minus 1 plus 3 minus x equal to 2. Now it is in the form of mod x minus 1 plus mod 3 minus x equal to modulus of x minus 1 plus 3 minus x. Get cancelled, that is equal to 2. Satisfies this condition. So simply you can write it as x, this as y. So x minus 1, 3 minus x greater than or equal to 0. Here multiply with minus, that implies x minus 1 and x minus 3 less than or equal to 0. X minus 1, x minus 3 less than or equal to 0 means, here if you take on number line these 1 and 3, less than 1 any value substitute negative and negative, positive, negative into negative, positive, here negative, here positive will get. For less than or equal to 0, x belongs to closed interval 1 to 3, or 1 less than or equal to x less than or equal to 3. This is our required answer for by this method. Okay, no? Now here I will give one condition, some conditions, one or two conditions are there here. Whenever x minus alpha, first one x minus beta less than or equal to 0 is there. Here if alpha is less than beta, again and again no need to take number line, directly you can identify the answer. So it can be written as alpha less than or equal to x less than or equal to beta. Definitely these values satisfies this condition. And the second one, suppose x minus alpha, x minus beta greater than or equal to 0. Here also if alpha less than beta, you can write it as x less than or equal to alpha, or x greater than or equal to beta. Less than or equal to least value, greater than or equal to greatest value. So here what is there? Less than or equal to is there, no? So if you write here x minus 1 and x minus 3, here less than or equal to 0 means 1 less than or equal to x less than or equal to 3. Directly you can write. Suppose if it is x minus 1 and x minus 3 greater than or equal to 0 is there means x less than or equal to 1 and x greater than or equal to 3. Like this we have to write directly. Okay, no? Now this is the solution of this equation by the first method. Now see the second method, that is also important one. Second method, that is modulus of x minus 1 plus modulus of x minus 3 equal to 2 given. Take the roots here 1 and 3 are critical points. Less than 1, here there are 3 cases. By the 3 cases we will solve this problem in the second method. First one is x less than 1, 1 less than or equal to x less than or equal to 3, x greater than 3. Suppose if you take here less than, here what we have to take? Less than or equal to. Here also less than, if you take, here also less than or equal to. Suppose if you are not taking means here we have to take, and here we are taking, here not taking means here we have to take, means finally complete solution is what? Same answer you will get. Now here I will take here equal and here also equal. There are 3 cases. By the first case, if you take the first case, if x less than 1, x is less than 1. So here whenever x less than 1, what is the behavior of this given equation we have to observe. So for that, here modulus means plus or minus, here also plus or minus. So for x less than 1, this is plus 1 or minus 1, plus or minus we have to identify. So nothing but behavior of whenever x less than 1, what is the behavior of this equation we have to observe. X less than 1 means any one value which is less than 1, substitute in this one. 0 I will substitute. 0 minus 1 means it is negative. So that's why given equation is what? If you substitute any value less than 1, 0 if you substitute it is negative, means minus of x minus 1. This is also negative, minus of x minus 3 equal to 2. Now minus x plus 1 minus x plus 3 equal to 2, right? Minus 2x plus 4 equal to 2, minus 2x equal to minus 2, x equal to 1. See here, x equal to 1 is satisfying this condition, that is also we have to observe, because whenever x less than 1, this is the procedure. It is not satisfy which condition? X greater than 1. So therefore there is no solution in this case, right? Now come to the second case. That is, if 1 less than or equal to x less than or equal to 3. In this case, any one value substitute. What is the in this for this condition? What is the behavior of this equation? We have to observe. So in between these two, one value I will take. That is x equal to 2. Substitute 2 minus 1 positive, 2 minus 3 negative. So this is positive. This is negative. So that's why given equation is what this is positive x minus 1, this is negative, so minus of x minus 3 equal to 2, right? Now here x minus 1 minus x plus 3 equal to 2, 2 equal to 2. So whenever LHS equal to RHL, it is true for all the real numbers. Not only it is true, it is true for all the real numbers. So it is also true for what? 1 less than or equal to x less than or equal to 3. So that's why in this case our solutions are what? 1 less than or equal to x less than or equal to 3. Now come to third case. In case 3, if x is greater than 3, if x greater than 3 means any value greater than which is greater than 1, you substitute 4 minus 1 positive, 4 minus 3 positive, means x minus given equation x minus 1 x minus 3 equal to 2, 2x equal to 6, x equal to 3. So here condition is what? X greater than 3. Here equation means solution is x equal to 3. Is it satisfying this equation, this condition? No. So that's why it is not satisfy this condition. So that's why here also there is no solution. Means so complete solution is what finally. So our complete solution is what? Complete solution is here there is no solutions and here there is no solutions. Only solutions are what? 1 less than or equal to x less than or equal to 3. So in second method also same answer you got. What is that? 1 less than or equal to x less than or equal to 3. So by the three cases we find the solution of the given equation modulus of x minus 1 plus modulus of x minus 3 equal to 2. Okay, modulus of x minus 1 plus modulus of x minus 2 greater than or equal to 4. In previous problem here equal is there. This is the inequality greater than or equal to 4 is there. Okay, no? Now if they given this type of problems, what we have to do? Here also same procedure, but instead of equal we have to take greater than or equal to. For this also I will do the two methods. So we know that in general modulus of x plus y less than or equal to mod x plus mod y. We know this condition. So by that condition, this can be written as, for that I will take the one consideration. Consider modulus of x minus 1 plus x minus 2 less than 4. Instead of finding the values of this one, first I will take this one, then I will conclude that. So modulus of x minus 1 plus x minus 2 less than 4. So by this condition, so modulus of, this is in the form of mod x plus mod y. So it can be written as modulus of x minus 1 plus x minus 2 less than or equal to mod of x minus 1 plus mod of x minus 2. Can you write by this condition mod x plus y less than or equal to mod x plus mod y. It is given, so means we taken this as less than 4. Now compare these two. That implies mod of 2x minus 3 less than 4. Now again it is in the form of mod x less than a. This mod x less than a, how to write? So 2x minus 3 minus 4 less than 4, because it is in the form of mod x less than a. It can be written as minus a less than x less than a, right? Now this can be written as, we have to eliminate minus 3. So for that minus 4 plus 3 less than 2x less than 4 plus 3. So minus 1 less than 2x less than 7. Next minus 1 by 2 less than, divide by 2 which is greater than 0. Now x less than 7 by 2. This is the solution for what? Mod x minus 1 plus mod x minus 2 less than 4. It is a solution for what? Modulus of x minus 1 plus modulus of x minus 2 less than 4. But we have to find the solution for what? Greater than or equal to 4. Is nothing but here suppose here minus 1 by 2 is there, here 7 by 2 is there. So this is the solution for this one means for the greater than or equal to what? This one and this one will take or not. Means so therefore solution of modulus of x minus 1 plus modulus of x minus 2 greater than or equal to. So this is solution for this one. But greater than or equal to 4 means except these means minus infinity to close interval minus 1 by 2 union 7 by 2 to infinity. So that is also can be written as or x less than or equal to minus 1 by 2 or x greater than or equal to 7 by 2. This is our required solution by the first method by using this condition, right? And now in the second method, how to do this problem? Method 2. Here also we have to take the what critical points 1 and 2 here. Here also there are three cases. One is less than 1, one is 1 less than or equal to x less than or equal to 2, and third one is greater than 2. So take the case 1. In case 1, x is less than 1. So whenever x less than 1, what is the behavior of this inequality we have to identify. Less than 1, any one value substitute. 0 I will substitute. Here negative, this is also negative. Means given equation becomes minus of x minus 1 minus of x minus 2 greater than or equal to 4. Simplify. Minus x plus 1 minus x plus 2 greater than or equal to 4. Minus 2x plus 3 greater than or equal to 4. So minus 2x greater than or equal to 1. So 2x less than or equal to minus 1. X is less than or equal to minus 1 by 2. Next, so is it satisfying this condition once you see? So x less than or equal to 1. Here x less than or equal to 1. Less than or equal to 1 means this value what satisfy which condition? X less than 1 condition. So that's why x less than or equal to 1 by 2 is a solution for what? Given inequality in this case. Next, second case, 1 less than or equal to x less than or equal to 2. Right? Now here also any one value substitute 1.5 you substitute here positive, this is negative. So given equation becomes x minus 1, this is negative, minus x minus 2 greater than or equal to 4. So x minus 1 minus x plus 2 greater than or equal to 4. These two get cancelled. Here 1 greater than or equal to 4. This is what? False. Means it is not possible. So once again see between any two values 1.5 I will substitute here positive x minus 1, it is negative minus of x minus 2. So x minus 1 minus x minus of minus plus 2 greater than or equal to 4. Minus 1 plus 2 is 1. Is it true? No, it is a 1 not less than greater than or equal to 4. So there is no solution in this case. Next come to third case. So case 3, that is if x greater than 2. Here also x, any x value which is greater than 2 substitute in this inequality. So 3 positive, this is also positive. Means given equation becomes x minus 1 plus x minus 2 greater than or equal to 4. So 2x minus 3 greater than or equal to 4. 2x greater than or equal to 7. X greater than or equal to 7 by 2. So here also this is also satisfies which condition? X greater than 2. So means here condition is x greater than 2. So it is satisfy which condition? X greater than 2. So that's why x greater than or equal to 2 are the solutions of the given inequality in this case. So finally, what is our complete solution? This one, x less than or equal to minus 1 by 2 or x greater than or equal to 7 by 2. It can also be written as minus infinity to minus 1 by 2 union 7 by 2 to infinity. So this is by the this is the solution of the given inequality by second method. Okay, now to do more problems based on this modulus, so I given one link in description, one link given. In that more problems are there. You can do more problems for the practice purpose. In this problem they given modulus of x square minus x minus 6 equal to x plus 2. So here also there are two cases, because this modulus x is nothing but plus or minus, means one case is greater than or equal to 0, one more case is less than 0 we have to take. Now take the first case, case 1. If x square minus x minus 6 greater than or equal to 0, right? Now take the factors for this one. X minus 3 and x plus 2 greater than or equal to 0. Can you take x square minus 3x plus 2x minus x and minus 6. Now if you take this one on number line, otherwise in last class we taken condition for this one. So how to get this one? X is less than or equal to minus 2 and x is greater than or equal to 3. Take this as equation number 1, right? And now whenever this is greater than or equal to 0, now given equation becomes x square minus x minus 6 equal to x plus 2. So these values take this side. X square minus 2x minus 8 equal to 0. Here also take the factors x minus 4 and x plus 2 equal to 0. So x square minus 4x plus 2x minus 2x and minus 8, right? Now here x values are minus 2 comma 4. After that these values satisfy the given this equation number 1 or not, we have to identify, we have to check, because whenever it is greater than or equal to 0, then only our solutions getting or not we have to check. X equal to minus 2 comma 4. So if you substitute x equal to minus 2 here, x equal to 2 is there. So x equal to minus 2 is the solution of the given inequality, given equation in this condition. And x equal to 4 also, greater than or equal to 4 means, so this is also solution of the given equation. Means these two satisfy equation number 1. So therefore these two are solutions of the given equation. Next come to the case 2. So what is the case 2? That is if x square minus x minus 6 less than 0. So here also take the factors x minus 3, x plus 2 less than 0. Whenever x minus alpha, x minus beta less than 0, alpha less than beta less than alpha less than x less than beta. Otherwise take these two are number line. So how to get minus 2 less than x less than 3? Now take this as equation number 2. So whenever it is less than 0, here minus we have to take, minus of, therefore given equation becomes minus of x square minus x minus 6 equal to x plus 2. Multiply with minus, minus x square plus x plus 6 equal to x plus 2. So here x get cancelled, this one take that side. Now x square equal to 4, x equal to plus or minus 2. Now in this one minus 2 substitute here minus 2. So these two values satisfies equation number 2 or not, we have to check. So x equal to minus 2. Here minus 2 less than x is there. So that's why x equal to minus 2 is not a solution for the given equation in this case. So that's why only x equal to 2 is a solution, because x equal to 2 means x less than 3 means x equal to 2 satisfies this condition. So that's why x equal to 2 is a solution of this given equation. Means totally complete solution is what? X equal to minus 2, 2 and 4. So these three values are satisfies the given equation. Otherwise you can check x equal to minus 2, if you substitute in this given equation, minus 2 whole square 4 minus of minus plus 2 minus 6 equal to minus 2 plus 2. So 6 minus 6 and 0 equal to 0, satisfied. Next to take the x equal to 2 also. If you take x equal to 2, so here modulus of 4 minus 4 minus 6 equal to, so 2 plus 2, this is 4. Here 4 and x value is 2, here 2. Now that is 4 minus 8 equal to 4. Modulus of minus 4 equal to 4 equal to 4. Once again see, x equal to 2, if you substitute 4 minus 2 minus 6. So here 4 minus 8, modulus of minus 4 is equal to 4, 4 equal to 4. Otherwise, you substitute x equal to 4 also. This is also satisfies given equation. So that's why these three are what? Solutions of the given equation. Okay, no? So whenever they given this type of problems, what we have to take? This is positive means greater than or equal to 0 one case. After that, so this is positive means this is equal to this one. Then you will get the solution. This solution satisfies this equation number 1 or not. We have to identify. And the second case is whenever less than 0. So we will get some more solutions. This solution satisfies the given equation number 2 or not. We have to check. After that, here solutions union. This solutions is the complete solution of the what given equation. Okay, no. Next, suppose they will give what this type of problems. What here less than or equal to or greater than or equal to inequality they given. Same as it is we have to do. But here in place of equal, what we have to take? That given inequality we have to substitute. Okay, no. Right. Seventh problem. Solve the inequality. Modulus of x square minus 2x minus 3 less than 3x minus 3. This is also most important problem and easy also if you observe carefully. So like previous problem only, but inequality they given. So here also there are two cases. First case is if x square minus 2x minus 3 greater than or equal to 0 we have to take. Now take the factors for this one. X square minus 3x plus x minus 3 greater than or equal to 0 means x minus 3 x plus 1 greater than or equal to 0. If you take on number line, you will get x less than or equal to minus 1, x greater than or equal to 3. Take this as equation number 1. Now whenever it is greater than or equal to 0, the given equation becomes x square minus 2x minus 3 less than 3x. This is greater than or equal to 0. Now simplify this one. That implies x square minus 5x less than 0. That implies x into x minus 5 less than 0. Now here you can write it as x minus 0 into x minus 5 less than 0. Now how to write it as? If you take a number line 0 less than x less than 5. Now take this as equation number 2. Now after that what we have to observe, these values satisfies given equation or not. Previous problem, so here there are no inequalities, but here inequality is there. So that's why what we have to do, so better you take common values of these two, means intersection we have to take. So that is 1 intersection 2. So that is how to take intersection. These values you take on number line. This is minus 1, 0 and 3, 5. Equation number 1. So less than or equal to 1 means like this. Greater than or equal to 3 like this. And this is open interval 0 to 5. So open interval 0 to 5. Now common values here to here means x belongs to closed interval 3 to open interval 5 means that is 3 less than or equal to x less than 5. Take this as equation number 1. Now in case 1, so greater than or equal to 0 you taken because this is plus or minus, this is greater than or equal to 0. So these conditions from this one x minus 3 x plus 1 greater than or equal to 0 taken as 1. After that you simplified 0 less than x less than 5. So these values satisfies this equation or not, we have to check. For that one what we have to do, here x equal to 0 comma 5 means easily you can identify like that. But here inequalities, here also inequalities. You take a number line. Then common values of equation number 1 and equation number 2 is this one. That one you take as A. Next come to case 2. That is if x square minus 2x minus 3 less than 0. If you take the factors x minus 3 x plus 1 less than 0. If you take these on number line, minus 1 less than x less than 3 you will get. Take this as equation number 3. Right? Now, if it is less than 0 means the given equation becomes minus of x square minus 2x minus 3 less than 3x minus 3. Simplify this one, minus x square plus 2x plus 3 minus 3x plus 3 less than 0. That implies minus x square minus x plus 6 less than 0. Multiply with minus x square plus x minus 6 less than becomes greater than 0. Now take the factors. So equation number 1 I am writing here, that is 3 less than or equal to x less than 5. This is equation number A from the case 1. Now here take the factors. X square plus 3x minus 2x minus 6 greater than 0. X plus 3 x minus 2 greater than 0 means x is less than minus 3, x is greater than plus 2. Take this as equation number 4. Now these values also satisfies this condition or not, we have to observe equation number 3. So for that what we have to take, 3 intersection 4 we have to take. That is, so here minus 3, minus 1 and 2, 3. So first equation is open interval minus 1 to 3. And this fourth equation is less than minus 3 this side and greater than 2 that side. What is the common area? Means common values are this one. Means here x belongs to open interval 2 to 3. That is nothing but 2 less than x less than 3. This is take as equation number B. So from case 1, this one 3 less than or equal to x less than 5. From the case 2, 2 less than x less than b. Right? Equation number 1 and 2 intersection values you taken. Equation number 3 and 4 intersection. So from the equation of case 1, A values means A means these are the solutions, and from the equation number means intersection of 3 and 4 B equation. So for these two, so union we have to take, means this values union this values, that is so A union B we have to take. Once again listen. So in case 1, 1, 2 intersection, in case 2, 3, 4 intersection. But A and B union we have to take. Now this is complete solution. That is 2 less than x less than 3 union 3 less than or equal to x less than 5. Means that is nothing but what? Closed interval x belongs to closed interval 3 to 2 to 3 union closed interval 3 to open interval 5. So finally how to write it as 2 less than or equal to, so here it is open interval 2 to 3 means 2 less than x less than 5. This is our final answer, right? Means x belongs to open interval 2 to 5 means A 3 less than or equal to x less than 5, B 2 less than x less than 3. So here x belongs to open interval 2 comma 3 union 3 to close interval 3 to 5 means finally how to write it as open interval 2 to 5 because these values in between 2 and 5 you will get. Okay, no? So this is about the 7th problem. Okay, no? So like this we have to do whenever they given inequality, and solve the one more problem. Solve the inequality modulus of x square minus 4x less than 5 given. Do this problem. Right. Now these are the some important problems on modulus function we did. Okay, no? In the next video, so next functions I will introduce. Okay, no? Right. Don't forget to subscribe our channel. So DSR, Maths, IIT and JEE. Okay, no? Okay, thank you.